Hello students, in this video we are going to discuss CBSE class 9 maths chapter 7 triangles, the third question in exercise 7.1. So let's look into the question, children. Here we are given that AD and BC, so AD, so this line, and BC are equal perpendiculars to a line segment AB. Okay, so from AB these two are going to be equal. That means we are given that AD is equal to BC. We are asked to prove that CD bisects AB. CD is bisecting AB. That means we are asked to prove that this and this are equal. That means we are asked to prove that OA is equal to OB. Is it clear, children? So this is what we are asked to prove. Now let's do this question, children. First we have two triangles here, isn't it, children? So we once we look into this, we can say that we have two triangles here, so which are going to be OAD and OBC. Okay, so we have two triangles. So now we'll get into the proof. So we have two triangles OAD and triangle OBC. Okay, so see this triangle OAD. I'll tell you why I wrote like this. Okay, OAD, and then so when I consider another triangle here, I want to consider it in a similar fashion. So where here I had the right angle, right? So here also I need to have the right angle. So my B will come here. Okay, so then it can be O can be here, C can be here. Okay, so it will be OAD and OBC. We've got these two triangles here. Is it clear, children? So now for these two triangles, we already know that OA is equal to OB. What is equal? OA is equal to OB. Sorry, we have to prove this OA is equal to OB. Okay, so we have these two triangles. So OA is equal to OB is what we need to prove. But what do we know? We know that AD is equal to BC. We know that AD is equal to BC, and we also know that this angle and this angle are vertically opposite angles. We know that angle DOA and BOC, that is angle DOA is equal to angle BOC, that is they are vertically opposite angles. Vertically opposite angles. So which angle? So we have angle DOA and angle BOC. So we have two angles equal and we have two sides being equal. Okay, so we also know that when already two angles are equal and when one side is equal, two angles and one side, so I can tell it as AAS, isn't it, children? We have AAS criterion. So when I discussed with you the ASA criterion, I also told you about the AAS criterion also. If two sides, if two angles and one side are equal, one side are equal, you can call it to be AAS congruency. AAS congruency. So as per this AAS congruency, we can say that the triangle OAD is congruent to triangle OBC. If two triangles are congruent, all the sides are going to be equal, all the angles are going to be equal. So in that case, automatically we can say that side OA is equal to OB. So with this we can prove, isn't it, children? So with this we can say that we have proved, or we have shown that. So we can say I have shown that CD bisects AB. So therefore CD bisects AB. So this is the answer. You must write the conclusion, children. If you just leave it like that, you will lose marks. Okay. So now let's look into the question once again. You are given they are equal perpendiculars. Equal perpendicular means these two have right angle, and equal means these two are going to be equal. That means AD is equal to BC, and since they are perpendicular, you can say that angle OAD is equal to angle OBC. Okay. Then what did we see? We saw that these two are vertically opposite. So what we were able to say, angle AOD is equal to angle BOC. So with this, what do we have? Angle, angle and side. Okay. So thus we were able to prove the AAS criterion. Okay. If you have any doubt in this AAS criterion, please get back to the video where I have done the ASA criterion. Okay, if you get back to that video, you will be able to understand this concept. So this is the third question in the exercise 7.1, children. Okay, so if you have any doubt, please get back to the video once again and try doing it, children. Please don't make any mistakes while you are solving these kind of questions. These are very simple to solve. Okay, see you again with the next question in the upcoming video, children. Thank you, children.